Back again with a bit more progress on the old TV. Last time we had a zero convergence picture. All the three components were totally separated. All the colors were totally wrong, like a severe magnetization of the shadow mask, and we had no sound and no contrast, among other functions were dead. Well, the convergence problem, fortunately, was just a matter of adjusting the H-stat control. It wasn't bad, it just needed a little tweaking, and I got it to converge pretty nicely. Next, the magnetization thing. I thought it was some magnetization of the picture tube. Looked pretty much like it. So I used my handheld degaussing coil to try to demagnetize the CRT, but it didn't work. But then I thought maybe this huge metal shield that's surrounding the CRT, maybe this is magnetized too, and the handheld coil doesn't have enough power to demagnetize it. So I just temporarily wired the original degaussing circuit of the TV to 110 volts, just for a bit, to activate the original degaussing coil. It made a great boom, and lo and behold, perfect color. So it was the magnetization issue. Fortunately, I almost thought maybe the TV had an accident, maybe it fell and the aperture grill was, maybe it was dislocated and the tube would be scrap, but no, it was okay. What else? Oh yeah, the other problem, the no sound, no contrast, etc. All the voltages I could test from the main board, they are all okay. But then I went to this board, which has the tuner, the channel selector, and the power on logic, as the remote control sensor, the soft power on, etc. And I started testing voltages here on the various test points. And yep, I was missing the standby voltage, standby 12 volts. I was missing that. Among that, I was missing also the 5 volts supply. So then I decided to inject some 12 volts from some external power supply directly into the test point, and behold, the sound came on and the contrast and all the functions came on. So what actually happened is that the TV wasn't really on when I just shoved some B plus directly into it. So half of the functions were working and half were not. That's why it gave that weird picture with no sound, etc. So yeah, once I got that working, 12 volts standby, all the TV came on. It looked pretty great. But then I hit a problem with the relay that was in here for turning on the whole TV supply from the standby. It wasn't working. The relay wasn't responding to the power on signal when I pushed the power button on the TV. So I had to research, investigate more a little bit into the problem. And what I found was pretty complicated. So in order to get the startup circuit working again, I had to do quite a bit of work, which I'll show you in a moment. I had to make myself a schematic because it turns out it's pretty weird how they do it for the standby supply, the soft power on generation, etc. Well, here's the main TV chassis. You know, the old style power supply with the linear V plus regulator. Here's where the voltage enters, 110 volts AC. So there's a contact in here which goes to the other board, the tuner board, the one that's mounted on its side, on the front panel of the TV. And there's a relay in there which activates, it acts as a switch for the AC power that's coming in to the TV. So that turns it on. Obviously, this relay needs a standby power supply for its logic to work and the relay to activate when you push the power button or you send the power signal with a remote control, because this does support a remote control. But there's no standby power supply going into this board. There's no AC going into this board, at least at the first look. So how would that work? So then I started analyzing the thing, and actually here's the contacts on the relay board, the tuner board that go to the relay. There's this just one wire that goes into a transformerless power supply. You know, no transformer. It directly rectifies and smooths out the 170-ish volts DC directly from the AC supply. But as you see, there's only one wire. Where's the other wire? Where's the ground? Well, apparently it's really convoluted how they did it, because as this TV has a hot chassis, here goes the positive, here goes the 170 volts DC, and it goes back through one of these diodes on the bridge rectifier, you know, from ground, and then it goes to the neutral. So that's how it completes the circuit somewhat. That's how it extracts the power for the standby supply with just one wire. So if I'm not using a live chassis, this isn't going to work anymore. And on top of that, you'd think the relay would be a standard 12 volt job, since actually the standby voltage is 12 volts. It's marked R12 volts in the test point. But no, this is why the relay wasn't working, even though I was applying the R12 volt supply, and the TV was turning on, but the relay wasn't activating. Actually, since this is a transformerless power supply, this can only supply, you know, about 10 to 20 milliamps of current at most, with no transformer, no current limitation, aside from some big honking power resistors that were probably dissipating a lot of power in the original configuration. So yeah, actually the relay coil is actually a 100 volt DC coil. Never seen one of those. In fact, here's the relay itself. Maybe you can't see it, but it says it's a DC 100 volt coil. So the relay itself, the power for the relay comes after the rectification of the AC current directly from that. And then it goes through this big power resistor, you know, to bring it a bit down to about 100 volts DC for the relay. So this resistor is dissipating around 70 volts of voltage. That's the voltage drop in here. So I actually find this design pretty complicated just to turn on a relay, and they did all this just to avoid putting a transformer in here, which is what surprised me the most, that there's not a single transformer in this TV power supply. It's like, what, the Sony engineers of the 80s had a fear of transformers? I don't know. But the thing is, this isn't going to work with my new setup, so I had to modify this, obviously, and this is what we're going to see now. So this is what I'm planning to do in a nutshell. First, I'm going to build a little linear power supply to provide a standby 12 volts. I actually bought a small transformer and all the associated parts to make a little linear power supply for that. And this is going straight into the standby 12 volt test point. So I'm getting rid of all the transformerless crap, since it's not working now, since all the chassis is now isolated. The original 100 volt relay, this has to go. I can't use this. I don't have a way to provide the voltage for that. So what I actually did is I replaced this relay with a 12 volt relay, something more decent. And since, so I'm replacing that with a 12 volt relay. So I'm bridging the 12 volts I'm getting here straight into the relay contact that is controlled by a transistor, by the power on logic. Since this line actually usually had about 100 volts DC and not anymore, so I'm bridging directly the 12 volts into it. And so the new 12 volt relay has two sets of contacts. One of them will control, you know, the main power supply, the universal one that's providing the V+ and the 12 volts for the main chassis to function. And the other contact, I will use it to control the original degauss circuitry. for degaussing the picture tube every time the TV comes on. So I'll put my hands into these modifications and we'll see what happens. So I'll show you in a bit what I've been talking about. Here's where I inject the 12 volts DC directly into the tuner board. Maybe you can't see it very well. The yellow and the black wire, those are the 12 volts for the standby supply. The green wiring here, that's the bridge for the new relay to work. Here's the old 100 volt relay. Maybe now you can see it. Oh, it's a 100 volt relay. I extended the contacts and I put a 12 volt relay in its place. This one, in fact, since it's a little bit smaller than the other and it has more contacts, I decided to extend it. Here you can catch a glimpse of the transformerless power supply. You can see this capacitor, 250 volts by 10 microfarads. That's the one for the 100-ish volts DC, and these are one of the big-ass power resistor for power dissipation. This contact actually has this jumper in here, so when I remove this, this supply is totally isolated from the old AC stuff. What else? Well, here's the relay. Here's one set of contacts controlling the universal power supply. Haven't still built the linear power supply. Here are all the parts for it. I'm building a little linear supply for the 12 volt standby. Maybe I'll fit it in here. I have a bit of space left. And yeah, this is controlling directly the V supply, and the remaining set of contacts will control this, which is the original degaussing circuit. As you see, I have removed most of the original primary. You only have the fuse, the input component, and the PDC for the degaussing circuit. I got rid of all of the extra things. I don't want any remainings of the hot chassis in here. So yeah, I'll have to put my hands on it and give it a go. Okay, so here I'll show you my progress. I'm still using an external power supply for the standby 12 volts, but it's all wired up except for the degaussing coil, and I'll be using a remote control. Check this out. We have sound, we have automatic power on, and there we go, we have a picture with contrast in perfect color. Well, I can tell the CRT is a bit weak. Maybe you can tell too, it's not giving a good white balance. But it's pretty good for a 30-something-year-old tube. This is the picture control, this was the contrast. It's working. Yeah, you can see the noise is a bit yellow. I don't know if it looks like that on the camera. But yeah, I can turn it off now. The relay clicks and turns off the main power supply. So the only thing left to do, to get all the startup things working, is to actually build that linear power supply for the standby and convert the original degaussing circuit to 220 volts, because I think if I put 220 now as it is, I'll blow it up. I'll maybe have to replace the PTC with something a little more beefy, and I should be all set to calibrate it and put it back together, and that should be it.